Hi children, in this video we are going to discuss about rational numbers and their decimal expansions. From class 9 we have learned many things about rational numbers and their decimal expansions. What are the things we have studied from 9th standard? The decimal expansion of a rational number is either terminating or non-terminating recurring. The decimal expansion of a rational number is either terminating or non-terminating recurring. The converse of this statement is also true. What is the converse of this statement? That is, a number whose decimal expansion is terminating or non-terminating recurring is rational. If a number whose decimal expansion is terminating or non-terminating recurring, it will be rational. These two things we have studied from 9th standard. Here in 10th standard we are going to learn when the decimal expansion of a rational number is terminating. That is, when the decimal expansion of a rational number is terminating, and the second one, when the decimal expansion of a rational number is non-terminating, repeating or recurring. These two things we are going to discuss now. That is, when the decimal expansion is terminating and when the decimal expansion is non-terminating, recurring. Now consider a decimal number whose decimal expansion terminates. For example, 4.2. 4.2 we can write 42 by 10. 42 by 10. Now factorize 42 and 10. 42 we can factorize 42 by 2 equal to 21. 21 by 3 equal to 7. That is 42 equal to 2 into 3 into 7. By 10 we can factorize 2 into 5. 2 into 5. We can cancel 1, 2. That's equal to 3 into 7 by 5. 3 into 7 by 5. Here the denominator of the rational form is 5. Note the point, denominator is 5. Now consider another number with terminating decimal, 1.25. 1.25 we can write 125 by 100. 125 by 100. Now factorize 125 and 100. 125 we can write 5 into 5 into 5. By 100 we can write 10 into 10. That is 2 into 2 into 5 into 5. We can cancel 2 5's from denominator and numerator. 5 5 5 5 cancelled. That's equal to 5 by 2 into 2. 2 into 2 is 2 square. Here the denominator contains the prime number 2. 2 only. Now consider another example with the terminating decimal, 0.85. 0.85 we can write 85 by 100. Now factorize 85 and 100. 85 we can divide by 5. 1 5. Then 35 we have 7 5 17. So 85 equal to 5 into 17. 5 into 17 by 100 we can write 2 into 2 into 5 into 5. We can cancel 1 5. 5 5 cancel. That's equal to 17 by 2 into 2, it is 2 square. 2 square into 5. Here just note that the denominator of these fractions contains the primes 2 and 5. The primes 2 and 5. Look at the first example, 4.2. The fraction form is 3 into 7 by 5. Denominator contains 5 only. The prime number 5. And in second example, 1.25 equal to 5 by 2 square. 5 by 2 square. Here the denominator contains the prime number 2. The prime number 2 only. And in third example, 0.85 equal to 17 by 2 square into 5. Here denominator contains the primes 2 and 5. 2 square into 5 contains the prime number 2 and 5. In all these examples, we have the prime factorization of the denominator has only powers of 2 or powers of 5 or both 2 and 5. In some examples, denominator has only powers of 2. In some examples, it is powers of 5 only. In some examples, both 2 and 5. That is, the denominator of all these rational numbers is of the form 2 raised to n into 5 raised to m. 2 power into 5 power. In all these examples, the denominator of the rational number is of the form 2 raised to n into 5 raised to m. This result can be written as a theorem. Theorem 1.5. Let x be a rational number whose decimal expansion terminates. Then x can be expressed in the form of p by q, that is the rational form, where p and q are coprime, and the prime factorization of q, that is denominator. The prime factorization of q is of the form 2 raised to n into 5 raised to n, that is 2 power into 5 power, power of 2 into power of 5, where n, m are non-negative integers. That is, if the decimal expansion of a rational number terminates, then its denominator is of the form 2 raised to n into 5 raised to m, that is power of 2 into power of 5.